Our next speaker is Sean Sarran. Has a Bachelor of Engineering in Civil Engineering, and a master's in civil engineering. He's a lecturer in the Department of Civil Engineering at the University of Guyana, Georgetown. He is researching the effects of mixing autonomous and human-driven vehicles. Today, he's going to talk to us about mitigating crash risks through the use of intelligent transport system. Please join us.
Okay, good day. I trust that everyone's hearing me quite clearly.
Very clearly.
All right, great. So I will just attempt to share my screen here. All right. So yes, so good afternoon to everyone here, the moderator and colleagues, viewers. So the topic that I'll be presenting today is mitigating crash risk through the use of ITS applications. Now, this is a summary of a bit of work that I did, and I'm trying to. The aim today is to try to maybe show how some of these ITS applications could be. Show you the strengths of the application rather, and then show that it could be applicable to Guyana. Now, as I said before, my name is Sean Sarran, and as the moderator would have said, I have a Bachelor's of Engineering and a Master's of Engineering. The first one is from the University of Guyana, and the Master's that is from Carleton University in Canada, where I'm also pursuing the final year of my PhD studies. So the presentation has the following outline. I'll just give you a little bit of an introduction on ITS and an overview on crashes. I'll delve a little bit further into like ITS and some examples, and try to explain, give an explanation there on the mitigation, the crash mitigation. How does that come about through ITS, as well as show its applicability to Guyana, before finally providing with some conclusions. So, as you would know by now, ITS it stands for Intelligent Transport Systems, and what it does, it integrates several different aspects of the transportation environment, and which includes vehicles, roadside structures, or roadway structures, and it also does include management techniques as well. Now, the purpose of ITS is that it can increase the road traffic and user safety, and it could overall benefit the transportation network through improvement of efficiency as well. Being that this is a conference related to trauma, I've decided to highlight basically the topic of safety as it relates to ITS. Now, usually worldwide, not depending on any country, any particular country, wherever you are in the world, you will have common factors for crashes, and you will have different factors that contribute to crashes as well. So one of the questions is that I would ask is, why in Guyana, for such a small population, do we have such a high rate of collisions on our roadway? And then there are some countries where we have populations that are well into the millions. Why do these countries have less per capita collision? Now, like I said, some of the situations, they're different, some are similar. Now, when it comes to the actual crashes on the ground, it depends on the situation or the vehicle situation during that crash encounter that it will determine the type of crash or the type of occurrence that happens. So we just had the previous speakers spoke about rear end and right angle type collision. So that's what we mean when we speak about the vehicle's situation or position on the roadway. Now, the very first speaker in this session spoke about crashes worldwide and crashes in the country being of a very high number. So worldwide, they actually contribute to thousands of deaths and millions of injuries per year. And this is this information. It's just not pulled out of thin air, but it's actually information that comes from the WHO, the World Health Organization. Now, in terms of ITS, how do they reduce crash risk? Is they do that in such a way, in a way such that they support drivers. Sure, they can monitor the state of the driver. So I'll give you an example. There is technology out there that can actually monitor a driver to say if he is sort of impaired from alcohol use. There is technology out there, so we can have technology that monitors the state of the driver. We could have that technology that gives information to a driver. So you drive along a roadway and you will see a stop sign, you'll see a traffic light. That is information being provided to the driver. The ITS applications, they support these measures that are already in place, and they provide additional information to the driver. They can also influence driver action by if a driver is notified of a possible collision, they can take evasive action to prevent that crash. In new and upcoming technologies for vehicle, we actually have those that can actually seize control from the driver and use the onboard computer to perform the driving task as well. Now, the scope of the presentation here is just to present to you the safety-related ITS, not the ones that will guarantee efficiency and all that other stuff, but the ones that are focused on safety. There's different types of ITS applications, so I'm going to zero in on the active ones, and basically will not be touching on the vehicle technologies, because when it comes to government's implementation of programs in the country, it's much simpler to develop a policy and a program around implementing roadway or roadside technology rather than mandating vehicle users to have that technology. So I'm going to zero in here on basically the roadway-based ITS devices. The objectives is to basically explore all the possible literature that I could have on these ITS applications, and zero in on the active ones that are, like I said, in the scope, that are road-based, and also evaluate the applicability of the ITS systems regarding different vehicle types. Now, when it comes to crashes, they don't only cause death. They can cause injury. Sometimes those injuries are permanent, and they can also cause damage to property. However, in terms of trauma, I don't know how much damage to property can be, but the last two there in the 3-item list, the injury and loss of life, those can have a very damaging effect on the individual themselves, or if we have a death and other people were involved in a collision with that deceased person, then we can have some trauma issues there as well, mentally, and we could also have physical trauma as well. Now, crashes also they involve both fixed and movable objects, but there's also some other events that exist. Now, this slide shows a table of motor vehicles involved in collisions. It also shows the amount of fatal collisions, personal injury collisions, and property damage. So there's 3 that I just mentioned. If you take a look at those numbers, and if you just simply glance at the total, 344,000, like just to the eye, that just seems like a lot, right? But this is the reality that we live in. And we can see also from that table the various types of objects that are related, that are involved in the collision with the vehicles. So those are that table, rather, when it comes to the class of the collision and the objects that the vehicles are involved with. This is the information from Ontario, Canada. Now, when we look at other influences or other or factors that can cause crashes or roadway crashes, we can see here that there's 5 of them, and one of them lies solely with the driver, right, which is referred to as the vehicle operator. Other issues besides the driver causing the collision could involve the mechanical condition of the vehicle, the roadway condition, weather conditions in which they have to drive in, or simply the geography of the roadway, right? So some areas with hills and valleys, they will have what we call a lot of vertical curvature, vertical curved roads, and those could have an impact on crashes as well. Now, straight on to the ITS applications here. You can see in the diagram we have in-vehicle infrastructure and cooperative systems. Now, the cooperative system it has a combination of or the technology is placed on both the roadway and in vehicle. So that's why it's called a cooperative system. The exchange of information happens between the vehicle and the infrastructure as well. Now, as part of each one of those systems, we have active, passive, and combined. So the combined is in the sense of both active and passive. The device can serve as both an active and a passive means, or in both active and a passive capacity. Now, what is the active system, right? So if you think active, think proactive of the term proactive, and this is what it does, right? It prevents a crash from occurring. What they do, they analyze the driving environment, and then they put that information forward to the driver. But like I said, some of the newer vehicles that are being developed, they actually could take control from the driver and control the vehicle and totally avoid a collision from happening, right? Because what happens in that instance is that the vehicles, they tend to have an even lesser reaction time than a driver would, right? So they're able to react faster, and that could be the difference between a crash or no crash. Now, the active system, it could be for in-vehicle, it could be for infrastructure, it could be for cooperative, as previously described. So here is some of the active systems in each of the classifications. So the in-vehicle, the infrastructure, the cooperative, and these will be discussed later on when I show the applicability, or explain the applicability rather. Now, the in-vehicle system, they utilize the technology within the vehicle. They collect data, they process this data, and they analyze it. They then take that data, and this is the computer processing unit I'm talking about in the car, and relates that information to the driver, warns him or her of the risks. But like I've been saying throughout the presentation, it can take control of the vehicle. I think I've made that very clear by now in this presentation. When it comes to infrastructure-based system, this is technology that's mounted somewhere on the roadways, whether it's the roadside or above the roadway, and it gives information to the driver. And that information somewhat helps the driver to make a decision before reaching a certain point where the potential collision lies. It does detect condition as well that maybe cannot be detected by the in-vehicle systems. And the cooperative systems, they establish a communication path between the vehicle and the infrastructure. And this happens on a one or a two-way basis, right? So one way simply is just information going from the infrastructure to the car. But the two-way, it's the car maybe asking for information and receiving it as well. So this is just a little diagram here showing just some of the ITS applications and the functionalities between vehicles, and we can see the other vehicles on the road. So those would be vehicles communicating with vehicles, but then you also have the the infrastructure here that the vehicle can be communicating with as well. Now, a look at the literature, and mind you, this data is primarily on ITS applications for in-vehicle technology. So that's why there is sort of like an area here to be looked at, which is the effectiveness of the roadside ITS applications. So these are all ITS applications for in-vehicle, and it shows very high levels of effectiveness in reducing crash. So we see values as high as 50% crash reduction. And these all come from various studies that have been done across the world on these ITS applications. So specific applications for Guyana's context, and I just wanted to highlight a little bit about Guyana here and how this could benefit us as the citizens and the residents. Well, the road-based systems that could be applicable to us would be the signal systems, the weather system, the animal detection system, speed adaptation, and warning system. So let's see how what some of the subsystems would be. So I'm not going to go through each and every one of this, but I'll just state, for instance, the weather and environmental information monitoring maintenance. This can give a driver information on visibility. That's one. And wet conditions, right? For whatever reason. Now there could be other reasons we can incorporate here, but these are two of the main ones: the low visibility and the wet conditions, right? Now, who benefits, or what vehicle type or what vehicle operators benefit from these technologies? You can see in this table here, nearly all the types of vehicles, cars, SUVs, commercial vehicles, motorcycle, and smaller trucks. Every single one of these systems contribute to prevention of crashes, or has an influence on preventing crashes when it comes to all of the previously mentioned ITS applications. Like I said, one of the areas to be that I see as necessary to explore is how effective rather can these systems be proven, or can these systems be effective in terms of preventing injuries or preventing deaths. This is an area that's left to be explored. So in conclusion, I would like to restate that the road crashes, that they do result in a large number of fatalities and injuries every year, and that these ITS devices, applications that put forward here, can definitely be effective in reducing or mitigating those crashes. The roadside systems compared to the in-vehicle systems are much easier to be implemented, especially in a country like Guyana. In more developed nations where car manufacturing occurs, policies can be implemented by federal government, or whether it's a provincial or state government, to mandate those manufacturers to put certain technologies on their car, right? But in Guyana, we don't have those car manufacturers. So I think the road-based systems will be better, or will be much easier to implement. These applications do benefit all types of road users, and they would definitely be a good addition to the road through crash reduction. So I thank you for listening. I may have gone over my time, but thank you so much, and I wish you all a wonderful rest of the day.